Hi everyone and welcome to the homework video. It's the first one of two in a series about fractions. I know it's an area that people can find difficult, so we're going to have a look at some types of questions, fraction questions this week. So for example, finding fractions of amounts, finding equivalent fractions, and we're also going to have a look at ordering fractions. They'll be more difficult as well than the questions just on here. And then next week we're going to come to look at adding and subtracting with fractions, converting fractions into decimals, and also looking at fractions as mixed numbers. Really look forward to seeing how you get on. The crucial thing to understand with fractions is this idea that fractions that might sound different and look a bit different are actually the same. 2/3 here we can see is the same as 4/6. We know that this is 2/3 because for every 3 sections 2 are shaded in. There's a total of 3, 2 are shaded in. Now of course that in many ways is the same here because for every 3 sections 2 are shaded in. The only difference, of course, here is that there are 6 sections. Now consider the news report here. English is a language spoken by 2/3 of Europeans. Now, of course, 3 would be the total, 2 would be the part, but that's not to say there are only 3 Europeans and 2 of them speak English. It's just saying for every 3 people, 2 of them will speak English. And that, of course, can be multiplied up however you like. Now, in actual fact, there's more like 300 million Europeans, so there must be about 200 million that speak English. It's an equivalent fraction. Now, your first challenge is to make 2 fractions that are equivalent to 3/5. Each of those fractions must use the number 60. Pause the video and have a go. The key skill to understand here is that whatever we do to the bottom of the fraction, whatever we multiply it by, we must do the same to the top of the fraction. So to make 3/5 out of 60, I've got to multiply it by 12. So I must have to multiply the top by 12 as well. So that will mean 36 out of 60 is the same as 3/5. Now, for the numerator to be 60, obviously I'll have to multiply both the numerator and the denominator by 20. So that will mean 3/5 is the same as 60 out of 100. Now, in the same way that we can find equivalent fractions by multiplying, we can also find equivalent fractions by dividing, if the top and the bottom will divide by the same number. See if you can cancel down or simplify these 2 fractions. So for the first one, 15 and 18 will both divide by 3 to leave 5/6. Of course, I can't divide 5 any further because it's a prime. And 14 and 35 both divide by 7. 14 divided by 7 leaves me with 2. 35 divided by 7 leaves me with 5. The key thing is spotting the factor that goes into both numbers. Now, finding equivalent fractions is very similar to finding fractions of amounts. If I'm trying to find 6/7 of 140, I would split the 140 into 7 pieces, each piece of course being of 20, and then I would need 6 of them, so I've got 6 of those 7ths. 20 times 6 would be 120. Now, the reason that's very similar to finding an equivalent fraction is actually if I'm finding 6/7 is equal to what out of 140, I need to multiply the 7 by 20 to make it out of 140. And similarly, if I multiply the 6 by 20, that will give me 120. Have a go at finding these 2 fractions of amounts. So 280 split into 7ths means that each 7th is 40. 40 times 7 is 280. So 3/7 must be 120. For the second question, if I can figure out that 1/20th of 200, 200 divided by 20 is 10, then actually I would say the easiest way to find 19/20ths is just to take 1/20th of 20/20ths, which will leave me with 200, which is 20/20ths, take away 1/20th, which is 190. Now, when it comes to ordering fractions, a fraction wall is very useful for giving a visual representation for the size of fractions. What I want you to do is to compare the size and order each pair of fractions. If you're feeling very brave, for a really difficult challenge, see if you can work out which fraction is exactly halfway between the other 2 in the pair. Now, for the first question, I've drawn a line where 5/6 are, which would be here, and then one where 6/7 are. I can see that 6/7 are bigger, and I would actually compare how far away they are from 1. So that would be 7/7 or 1, and that would be 6/6 or 1, and I can actually see that 6/7 are closer to 1 because it's only a seventh away, and that's a smaller gap, whereas that sixth away, that's a slightly larger gap. Now, I can make both fractions out of 42 to check the size, because 6 and 7 both go into 42. I'd have to multiply 5/6, the top and the bottom, by 7 to get 35 out of 42, whereas 6/7 I'd have to multiply the top and the bottom by 6 to make it out of 42. And I can see then that 35 out of 42 is smaller than 36 out of 42. To find the fraction halfway in between, though, I'll need to make the fraction out of an even bigger denominator. If I double those two fractions, I'll have equivalent fractions out of 84. 70 out of 84 is the same as 5/6. 72 out of 84 is 6/7. So 71 out of 84 must be halfway in between. That's an extremely difficult question. Well done to anyone who's got there. Similarly, to compare the size of 3/5 and 5/8, I'd want to get both fractions out of the same denominator. I can get them both out of 40. 3/5 multiply the top and bottom by 8 gives me 24 out of 40. 5/8 gives me 25 out of 40, so I can see that one's bigger. Now, if I'm trying to work out a fraction in between, again, I know that 24 out of 40 is the same as 48 out of 80. 25 out of 40 is the same as 50 out of 80, so halfway in between must be 49 out of 80. Again, well done to anyone who's got there. Now, for your final challenges, see if you can order the 4 fractions at the top, and then see if you can find a fraction, or even some fractions, that are between 3/8 and 7/16. Pause the video and have a go. Now, for that first question, the first thing I'd hope you'd realise is that 7 out of 14 is actually a half, because 7 is half of 14, whereas all the other fractions must be less than half, because their numerators are less than half of the denominator. So, then I'll just be comparing those other 3 fractions. If I make all 3 out of 30, I've got a way of comparing them, which I've done there. So, I know that the smallest one is 3/10. Then, it must be 5/15. Next, 2/5. And then my largest one, 7/14. Now, my tip for the bottom question is to make both fractions out of an enormous numerator. So, if I multiply 3/8, the top and the bottom, by 2, I'll make it 6/16. Now, how about we just multiply the top and the bottom by 100? That would give me 600 over 1600 being equivalent to 3/8, or 700 over 1600 being equivalent to 7/16. Now, for fractions in the middle, here are some examples. There's 601 over 1600, 699 over 1600, and anything in between. You might have found different ones with a different numerator and a different denominator, and that, of course, is great. Well done, we'll see you back in class, and the second part of the fractions video will appear next week.